Welcome to AMI Day 12. Today we're going to talk about applications with trig functions, specifically functions modeled by the sine and cosine, or transformations. Modeled using sine and cosine, or transformations of the sine and cosine. Cyclic phenomena such as phases of the moon, high and low tide, the pendulum on a grandfather clock, the height above the ground on a Ferris wheel, car on a Ferris wheel, this may be something you're not familiar with, but the stroke of a piston inside your engine in your car. Pumps work with a piston also, and the stroke of that piston on a pump. Different things. These functions are really versatile. And there's a lot of different things they can model, but pretty much anything that fluctuates between a high and a low place, high and low value, anything that fluctuates over time, most things that fluctuate over time, many things that fluctuate over time can be modeled using the sine or the cosine function. Remember, if we have a function f of x equals a times sine bx plus c plus d, or g of x equals a times cosine bx plus c plus d. In both these situations, a is the amplitude, absolute value of a, and that's the distance from the center line of the graph to the maximum or the minimum. This is the center line, and the amplitude is this distance right here. And we can always get that by doing the maximum y value minus the minimum y value and divide by 2, because of the way the behavior of the curve. B gives us the period, 2 pi over b, 2 pi over b gives us the period. And that's the length of one complete cycle. One complete cycle when the function begins to repeat the last cycle that it just did. And then, of course, the phase shift, negative c over b, and the vertical shift is d. If we can identify the max and the min this gives us the period, or sorry, the amplitude. if we can identify the length of one complete cycle, we know the period, that allows us to find B. Then we can shift the graph up, right, or left, up, down, right, or left, using C and D. And that's what we're going to be doing today. Let's look at a simple model. I've got 3 different ones for you. We may break this up into several videos because some of these are going to be kind of involved. Start with a simple one. Let's say we have a Ferris wheel. With a radius of 50 feet. And let's say that for a car on that Ferris wheel is at its lowest point on a ride, the height above the ground, is 3 feet. So let's think about this. We got a Ferris wheel. Here's a car at its lowest point, and that's 3 feet above the ground. At its highest point, because the radius of this Ferris wheel is 50 feet, this would be 100 feet from the lowest point to the highest point. The maximum height of the curve of the car is 103, and the minimum height is 3 feet. So we do 103 minus 3 equals 100, and 100 divided by 2 gives us 50. This is going to be the amplitude of our model. We're going to model the height above the ground. Let's say a car makes one complete cycle, or one complete revolution, in 1 minute. That means it goes from its highest point back to its highest point in 1 minute. That means the cycle is going to be repeated after 1 minute. I'm going to start repeating after 1 minute. So that tells me my period is going to be 1. So let's see what we can do with that. If we were going to start, let's say start this function with the car at the highest point. Then we know the amplitude is going to be 50, so we know that this function, let's call it h of t, the amplitude is going to be 50, so it's going to be 50. We got to decide if we want the sine or the cosine to model this. And so let's think about it. If we start at the highest point when time is 0, and we go to our lowest point, and we start a new cycle, when we get to the highest point, this looks a lot like the cosine curve. So let's use cosine. We need the period to equal 1, so that means 1 has to equal 2 pi over b, and for that to be the case, b has to equal 2 pi. So this is going to be cosine of 2 times pi times t. Since we're starting at the highest point, there's no need to shift this curve because the cosine curve naturally starts at its highest point. No need to shift this curve right or left. But right now, the highest point on this curve is going to be 50. We need it shifted so that the highest point is going to be at 103. So we're going to have to add 53 to that curve. And this is a model that will give the height of the car, if it starts at its highest point, t minutes, or t, yeah, this is in minutes, t minutes into the ride. So you can plug in 5 minutes and it'll tell you how high the car is above the car, above the ground. If we want to do that, let's say the ride lasts for 5 minutes. Well, let's not do 5 minutes because every minute repeats, so we know it's going to be back at its highest point. Let's do 2.3 minutes. H of 2.3. Now, we're set this in radians because we did the 2 pi. So, we're going to do H of 2.3, 50 times cosine. Make sure your calculator is set in radians or whatever you're using. And if we type that in, that tells us that the car is 37.549 feet above the ground after 2.3 minutes into the ride. But that's how we create a model for a trigonometric function. I'm going to stop this video and give you 2 more example problems on the next video.